So this one we have actually proven, but this is, I don't know how I should give it a name, but this is, yeah, maybe you can call it law about implication. Yeah, I don't know. So this is about the imply. So maybe you call it implication law or law about P implies Q. Then we understand. Okay. Okay. So we have all the laws. Then we can use the law to help us to prove some logical equivalences without using the truth table. So let us show some examples. So there are two examples. So first of all, we want to show that P implies Q, okay, is always the same as not Q implies not P. Okay. So this is something that we can use the meaning of P implies Q to help us to understand briefly why this is correct. So for instance, I just said that if I'm rich, I will buy him an ice cream. Okay? Okay, we don't know whether this is true or false, okay, but assume that this is true, okay. Then it is the same as, okay, let's take a look of what I'm going to say. Now remember, the original statement is, if I am rich, I will buy him an ice cream. Okay? So I can use the same, so I can reverse my wordings a little bit to mean the same thing. It says, if I don't buy him an ice cream, then I'm not rich. They're actually meaning the same thing, right? Right? So does it make sense? Okay, if I'm rich, I will buy him an ice cream. Then what does it happen if I don't buy him an ice cream? If I don't buy him an ice cream, then that means that I am not rich, if I'm not telling a lie. Okay, so it is similar here. If P, then Q, it is the same as if I'm saying, if not Q, then not P. Okay, now this is what we use in logic every day. And then how do we prove it? So we don't know whether this is true, but we want to prove it. So how do we prove? Okay, so let's use this implication law. Let's see if it helps. So P implies Q is equivalent to what? Equivalent to, so when is it true on the other hand? This is true when P is false, so not P, or when Q is true. Okay? Okay? And then this is by law 11. Okay? I should write down why I can write this down. Okay? And then this one is equal to what? It's equal to Q or not P, right? This is by the commutative law, law 5. Okay, so we should write down. I should exchange the order. It is the same. Is that okay? And then this is equal to what? This is equal to not of not Q or not P. This time it is the double negation law. Where is it? Somewhere 8. Okay, so 8. The double negation law. Is that okay? Is that okay? And then immediately this is equal to not Q implies not P. And this is the law 11 again. Is that okay? Law 11 says if you have not something or something, then it is this part implies this part. Here it is you have not something or something, so it is this part implies what? Implies this part. Is that okay? Does that make sense? So that's it. So we can prove without using a truth table. But for this case, it is still okay if we use a truth table. It is because they are just two variables. Okay? Okay, so here we are trying to show that P and Q implies P or Q is a tautology. Is a tautology. Okay? So we want to show this. Okay? So how do we show? Okay, so we hope to arrive at a conclusion that no matter you fit P or Q inside, it is always giving us true in the end. Okay, so let's do this. Okay, so we don't know. So this part is we don't know whether it is a tautology or not. But let us try to simplify this. This is very complicated. It has and, it has or, and it has an imply. Very, very complicated. So let's try to simplify it using this one is what? P implies Q. So P implies Q, it is not P or Q. Okay, so the not of the first part or the second part. Is that okay? So always remember to write down which law you are referring. So let's call it law 11. Okay, it need not be a law. It can be a result that you have shown. So you write down the result 1 in page 13, something like this, that you have proven. So here it just happened that it is 11 we have listed. So I call it law 11. By law 11, then this is true. Okay, then what? Oh, then De Morgan's law, right? We can use De Morgan's law. This is not P and Q, so it is equal to not P or not Q or P or Q. Is that right? Is that right? Yeah, so this is De Morgan. Okay, De Morgan's law. And then what? So we still have bracket here. We still have bracket here. We still have bracket. We still have bracket here. Then what should we do? So it could be very tedious. Or of course, you already understand this is true if you are using a truth table. But let us practice with our proof that it is going to give us a tautology by using step-by-step way. So here, this is a bracket, something, or P or Q, right? Then what should we do? Yeah, so associative law will allow us to make, we don't do this bracket first. We can do this two bracket first. So we will have not P or bracket, big bracket, not Q or P or Q. Is that okay? This is associative law. Okay? Okay? And then what? And then we have this part already. So we can, so this is equivalent to what? Equivalent to, so we write down not P, the first one, or this one, not Q or Q or P. Okay? And then which law I'm using? Anyone? Yes. The commutative law, right? So I'm exchanging P and Q. Okay, why I need to be very careful? Because it is not always true. Something is not always that any operation is commutative. So if you have studied matrix multiplication, let's say I have two square matrix A and B. A multiply B is not the same as B multiply A in general. So some operator is not commutative. So you cannot exchange the order. But and or, they are very simple. It turns out that they can exchange the order. Okay, so after exchange the order, then this will be equal to what? Okay, this will be equal to, so let's still write down not P or what? Or we can have not Q or Q or P, right? Right? And then this one, okay, now I'm lazy, okay. So I need to write down a few more lines. But you can see that not Q or Q is true. Okay, this is the whatever, the negation law. Okay, true or something is true because it is now dominated. Okay, true or something is true. And then true or something is true. Very good. So this one, after some step, you get a true in the end. So it is always true. Because it is always true for, we didn't make use of the exact value of P or Q. We don't know whether P is true or false. We don't know whether Q is true or false. But we still can deduce that the overall thing is always true. Then we call it a tautology. Okay? That's it. Good. Okay, now, so these are some practice. You can do a lot of it at home. Okay, you can create, check some exercises or check the assignment one that we have sent it to you already. You can do it. Okay, even for the same formula, you can try to prove it in different ways as a practice. You can use truth table to prove it. You can use this one to prove it. Or actually, you can use a combination of things to prove it. For instance, if you look at it, we want to show that it is always true. Okay, so first of all, we don't care the case where P, Q will give us false. P and Q false here, because if P and Q is false, we will get a true in the end. Does that make sense? So the only case that we need to care is when P and Q, this together will give us a true. And we also want to make sure that under this condition, you will get a true in the end. Does that make sense? So for instance, P is false already. When P is false, then this side is false. You get a true. When Q is false, this side is false already. You get a true in the end. So we don't care. So the only troublesome case is when this side gives you a true. And when will that happen? We will see that this side will give us a true when P and Q are both true. Okay, when P and Q are both true, then what will happen? Then P or Q will be true. Then true implies true, true. So you have actually looked at the truth table in a very quick way. Okay, and then you see that all the cases, it will give you a true. Is that okay? Good, very good. So you can practice at home. So these are easy things, okay? Tedious, but easy, okay. And now let us give you some logical puzzle. So it is about there is an island, okay? So in this island, so there are a lot of people living there. So many, many people, okay? So people are of two different types. So one is the true type people, true people, okay? True people always tell the truth, okay? If you ask him or her a question, he will answer you correctly, always. And there is another type of people, let's call it the false people, okay? It will always trick you. If you ask him or her a question, then they will tell you that in the opposite answer, with the opposite answer. So for instance, if I ask someone, am I a boy? Then if he says yes, then this is a true people. If he says no, then this is a false people. So they are very pure. So there is no people like random, okay? So a random people will give you random answer. Okay, now somehow you meet two persons, let's call it A and B. And then you overheard their saying. A says B is a true people. B is a true people. And then B says we are opposite. We are different type. We are of different types. Okay. Then can we make some conclusion about the type of people that A and B are? False, false. Both of them has to be false. Why? Okay, so there are two cases, right? Okay, let's say these people can really exist. So let us first check whether A can be false, A can be true. Okay, if A is true, then what does it mean? Then what he's saying is true, right? So B will be true. But in that case, if B is true, then he's saying something wrong. So here we will be sure that A cannot be true. Okay. but maybe A cannot be false again. But let's check. Okay. So if A is false, then what does it mean? B is false. And B is false, and it makes sense because when they are both false, then B is saying something wrong. We are of different type. Very good. Okay. Okay. So A and B, we actually find out that they are all from false. Okay. But there can be some trick here. Yeah. Let's see. I'll tell you about something wrong later. Okay. Very good. So this is the first puzzle that we have, and you see that we need to argue why this is true, why this is false through a lot of logical deductions. We need to separate it by cases and then find out there's something wrong happening. So it can't be true. So we are actually using some kind of proving techniques already. Okay? And it is actually one of the proof by contradiction that you have just used. And then, okay, another question. Okay. We will get back to a similar question of this one later. Okay. But let me quickly talk about another question. The next question is about a sad story. Very sad. Okay. Yeah, very sad. A sad story. Okay. Okay. A sad story. Okay. So this is about a town. Okay. So a town, there is a kind of a city hall. There is a clock there, a city hall that people meet. And then, okay, somehow very interestingly, that in this town, everyone has a dog. Dog. Okay. A dog. Okay, has a dog. Okay. Whatever. Okay. Oh, has a dog. Okay. So everyone. Okay. This little boy, this little girl, also has a dog. Okay, a dog. Okay. Okay. And now, okay, let's say there are many citizens here. Let's say there are 100 citizens here. Every one of them has a dog. And then, for some reason, some of the dogs are infected with some disease. Okay, and this disease will what? So if you have this disease, then this disease will be transmitted to another dog. So this kind of disease, we call it very contagious. So it is easily transmitted to the others. Okay. Now, some of the dog has disease. Okay. But every person loves their own dogs, okay? So that they can't see whether his or her dog is sick or not. Okay, I have a dog, but I can't tell. I can't tell. Maybe he's sick, maybe he is not sick. This dog, I can't tell. But for some reason, I can tell all the others, okay? Yeah, so I can tell all the others. But they are very shy. These people, they are very shy. They won't tell the others that, oh, your dog is sick, you should do something, okay? So they are shy, they can't tell the others, and they don't know their own dog is sick or not. But somehow, they all think that, okay, if you know that your dog is sick, you should do something on it. Maybe, yeah, let's say, kill it, okay? Or maybe you send it away to some hospital for 3 months to do some treatment. Okay, so what happens? Okay, so this somehow, one day there is a visitor coming from outside who okay, and then this visitor meets every one of us here in a meeting at the city hall, so everyone knows this visitor. And this visitor tell them one sentence, okay, at least one of the dog here is sick. Okay, so it looks like that it is some information that everybody knows, because they can somehow each of them see at least one dog to be sick, let's say. Okay, but this has a great effect. Okay, so this visitor is coming and saying something that everybody doesn't want to say. Okay, I saw some dog, and that some dog is sick. But this visitor says, some dog is sick, at least one of them. Okay, now, so because people there, they are all very righteous, they want, okay, then in that case, we have to do something. Okay, so what they do, okay, let's say, they agree that starting from today, okay, starting from the next day, at noon, if you know that your dog is sick, then you shoot, maybe shoot to the air or shoot to the dog. Okay, bang, there is a sound. Okay, but if you don't know, then you should do nothing because you don't want to harm someone that is not guilty, right? Okay, so okay, they all agree this policy. So on the first day, so after 1 day at noon, nothing happens. After another day, the second day, nothing happens. Okay, nothing happens, nothing happens, nothing happens. But on the 7th day, okay, there is some bang, 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 bang. Okay, okay. Now the question here is, okay, it's very strange. This question is, how many dogs are sick? Do you understand the question? Okay, so at the beginning, okay, so this is the policy. If you know, if you are sure that your dog is sick, you should bang, okay? If you do not know, you should do nothing, okay? So every noon is a checkpoint. So after 1 day at the noon, nothing happens. After the second day, nothing happens. But on the 7th day, so 1, 2, 3, on the 7th day, there is some bang that you hear. So in that sense, you know that some of the people are sure that their dogs are sick, and they bang, okay? The question here is, how do these people know? This is actually you need to answer. And then how many of them know? And then, of course, how many dogs are sick? This is the question, okay? Okay, so understand, right? Everybody understands, okay. Let me see. So all types of questions like this, we should not be fooled by this 7, this number. This number usually is useless, okay? So if it works for 7, it should work for 6. It should work for 5. It should work for 2. It should even work for 1, right? Okay, so let's make this problem the simplest one. Suppose that on the first day, you know that your dog is sick. How can this happen? How can I know the dog is sick? Yes?
No one else's dog is sick.
Very good, exactly. So if you see no one else's dog is sick, then you know your own dog is sick. Because you trust the visitor. The visitor says there is at least one dog sick. Okay, so if there is some bang that you overhear on the first day, that means that one of the people knows the dog is sick. That people has a specialty, okay? He's very special. He's seeing exactly no dog is sick. So using his logical deduction, he knows that his own dog is sick. Is that okay? Very good. Okay, now, let's say the first day, nobody bang. But still, on the second day, that you hear some bang bang, okay? Bang, 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 whatever, okay? Then how can the people on the second day know? But they don't know on the first day. So what happens? What happened? Yes? Too many dogs are sick. Okay, now, this is a good point. Because there are too many dogs are sick, so you don't know your own dog is sick on the first day. But then the question here is, how can they tell that their own dog is sick on the second day? No. You can see all the dogs, but you can never know your dog is sick or not. You remember, you love your dog a lot.
Because there are 100 dogs, and
yes?
maybe you have 2 days to check all.
Oh, no. Okay, so let me tell you. Okay, good point. But okay, even if you check all the dogs are sick, you still cannot tell your own dog is sick or not. You remember? Okay, so my key point here is that you kill only your own dog. You are not killing others' dog. Okay, so this is the point. Okay, everyone has his own dog. What you can bang is your own dog. Okay, or you do not. Okay, or you do not. Okay, or you do not. Okay, when you do this action is when you are certain that the dog is sick. Okay, so on the second day, even if you see all the dogs around, they are sick, it doesn't mean that your dog is sick. Yeah, it doesn't. It doesn't, because your dog can be fine. Yes?
Because you see one dog is sick.
Very good. Okay, and okay, here, his answer is because for those people who bang, they see exactly one dog is sick. They see exactly one dog is sick. Or what I should say is, altogether, there are 2 dogs sick. Altogether, there are 2 dogs sick. Okay, now when there are 2 dogs sick, okay, so let's say I and his dog are sick. Okay, your dog is okay, your dog is okay, your dog is okay. And then I'm standing here, okay, on the first day, oh, you should kill, you should kill. Yeah, because your dog is sick. And then if my dog is not sick, what will happen? He will kill his own dog, right? Yeah, on the first day, I'm very happy. He's going to kill his dog, or then my dog is okay then. But then suddenly, he doesn't kill his dog. Then what will happen? Then it only means that he also sees some dog around which is not sick. Which is sick. And that can only be my dog. You understand? Okay, and then on the second day, he and I are very, very sad. Because we are both thinking the same thing on the first day. Your dog is going to die, my dog is okay. Okay. But then on the second day, we are both very sad because I saw his dog, he saw my dog sick, and then we noticed that we can deduce that, we can imply that our own dog are both sick. Okay, because the action is he doesn't kill his dog, I doesn't kill my dog on the first day. So it has to be this dog is sick and his dog is sick. Okay, in that case, so if it is the second day that you heard bang, it means that exactly 2 dogs are sick. And then exactly 2 persons know their own dogs are sick. Is that okay? So if you understand this 1, 2, then you can argue this again and again. So on the 7th day, if there is some bang going on, that means that there are exactly 7 dogs are sick. Because none of these people are sure that their dogs are sick on the first 6 days. But on the 7th day, they are sure. Because this is the only reason why there are no people killing their dogs on the first 6 days. And it has to be their own dog is sick. Is that okay? Good. Okay, now let's get back to the true and false type people here. Also, there are 2 types of people. One is true type and one is false type. Okay, so there are true type and false type. Okay, let me see. Okay, so there is somehow you are a visitor in this country. You want to go to the city hall. Okay, so you are the visitor. Okay, actually. And somehow there is a road junction. You know that one side is going to the city hall that you want. Let's call it heaven. One side is heaven. Okay. And of course, the other side is hell. Okay. But you don't know. One side is okay, you don't know. You don't know which side it is. Okay. And there are 2 people standing here. For some reason, you know that one of them is true and one of them is false. They are of opposite. They are of opposite type. And then you want to get to the road to the heaven. Now here you can ask them. Okay, they are giving you one chance. Okay, you can ask them one question, and they can answer yes or no, and then you need to decide which way to go. Is it possible? And what? Yes. Okay. So, so some of you have heard of this one, right? Actually, this happens. This is one of the questions that is also inside a movie. There is a movie called Never Ending Story. Okay, a long time ago. Okay, so it's a very old movie, Never Ending Story. Ending. You may check it. Story in the Wikipedia for that. Perhaps they are going to make a remake of this one. Yeah, because it is quite interesting. Okay, now what can this question be? Okay. What can this question be? You know that they are of opposite type, right? Yes, yes. 可以用中文 Yes. Okay, 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 good, okay. Let me translate it into English. Let's say, yes, 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 very good, very good. Exactly. Okay, so let's call it A and B. There are two persons. And then what are you going to do? Ask A. Okay, now this is a very, you ask A what? Ask A. Okay, if I ask B, which way? Or because he's going to answer yes. Which way? Okay, let's say which way is to heaven? So what is B's answer? B's answer is what? Okay. So assuming that, okay, we are restricting A to answer this way or that way, okay? And then how does it help? Okay, so let's say A says, okay, this way to heaven, okay? So this is the answer. A says, so this is A, this is B. A says, this way, okay? Should you go this way or should you go that way? Let's check what happens, okay? So to solve this problem, we can actually use the truth table again. Because the truth table can capture what is going on. So there are two cases. Okay. So there are two cases, okay, 4 cases. So A can be true type or false type, right? Right? Let's say one side. Let's say this is the left side. Let's say this is the R side. Okay. So the other case is left is for heaven. Is it okay? Okay. Now, why don't I write down B here? Because B is actually dependent on A. If I know what is the type of A, then I know what is the type of B. Is that okay? So if A is of, so there are 4 cases that we should look at. True, true, false, false, true, false, true, false. Is that right? Truth table, right? This is the truth table, okay? Now, and then, okay, so this is the relevant cases that we should look at. Okay, very good. Okay, so is that okay? So if A is true type, left side is heaven, then B will say left side is not heaven. Am I correct? B will say right. You should go to the right side, right? Right? And then A will answer exactly because A is a true type. And A knows B's answer is right, so R. Is that okay? A is of true type, left side is not heaven. Then B's answer will be left. Is that right? Left side is not heaven, so he's not going to tell you where is the heaven. So it will tell you L, okay? L is not heaven, L. And then A's answer will be L. Is that okay? And if A is saying something wrong and L is heaven, then B's answer, B will be a true type. B is true type, so B will answer left. Very good. And then, but A is a false type. He knows B is answering left, so he will answer right. Is that okay? And the last one is A is false type, so B is true type. Left is not heaven, so the right side is heaven, so it is L. Is that okay? Okay. So where is the heaven? Okay. So where is the heaven? It depends on the answer to this one. So in this case, the heaven is on the left side. Is that okay? On this case, the heaven is on the right side, left side, and right side. And then this is A's answer. Okay, this is why the question you are asking A is helpful, because whenever L is heaven, A will answer right. Whenever L is heaven, A will answer right. And whenever right is heaven, A will answer left. Is that okay? So that means that this is useful. Okay, if A tells you the answer this side, you go this side. If A tells you the answer this side, you go that side. Okay, now, to end this class, I'm going to what? I'm going to make one extension of this one. Suppose that you just see one person here. Now, you don't know whether this person is a true type or a false type. You don't know. Is it still possible that you ask this person one question and then you can decide which side is heaven, which side is hell? Okay? Okay, so let's talk about this maybe on Wednesday. So this kind of logic puzzle. On Wednesday, I will give you another one. So you may search it on the web first. So the problem that I'm going to talk about on Wednesday is the hardest logic puzzle ever. Okay, I can tell you, okay, briefly, okay. So there are going to be 3 gods. One is true God, one is false God, and one is random God. Random. And then your task is to find out which one is true, which one is false, and which one is random. You can ask them 2 questions. You can ask them 2 questions. But then their language is different from yours. Okay. So they don't say yes or no. They say da or ja. And the problem is you don't know whether da is yes or ja is yes. Okay. Is that okay? So this is why this is hardest. Okay. There are 3 gods. You need to identify which one is true, which one is false, which one is random. And you can ask them questions. They understand your question. You can speak in Cantonese, Chinese, Japanese, English, whatever. Okay, but the answer is da or ja. Okay. And then you can ask them 2 questions only, and then you need to find out which one is which. Okay, da or ja. Okay, so let's talk about this question on Wednesday. Okay, thank you.